The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. Welcome back to the next class of chemistry. We are going to start a new topic today, biomolecules, which has got more of your biology content apart from the structures and the properties that we are going to learn in detail. And so when you are studying about this, definitely you have some knowledge about these topics in biology. So you can just correlate the same topics with what we are learning now. Of course, the organic part has got over. So once you come here, we'll be focusing mainly on the organic part about the reactions and how does these reactions occur, how can we remember the pathway of the reactions, or what is the mechanism, like how exactly these reactions are giving such products, how to remember the name reactions. All those we will be definitely learning in detail once you come here with proper revision. So do not get panic or do not get worried about how to approach for our exam. Definitely we are here to support you and be on with us together to achieve more in your exams. Be regular in that. And with this, let us proceed to the next topic, biomolecules. Any living system that we have, it grows and it reproduces. I would put in simple words that it grows, it sustains, it tries to live or exist in that particular period, and also it reproduces itself. The most amazing about this is that it composed of non-living atoms and molecules. Have you ever wondered about this, children? We are consuming a lot of things in our life, whatever we are doing, our body, maybe the food that we take, or the saliva that we have in our mouth, or anything that you do, it mostly comprises of non-living atoms and molecules. Such a knowledge of all these non-living atoms, which plays a vital role in our body, you call that as biochemistry. So here, biology plays a very important role in molding chemistry with the structures, applications, and how this can give rise to a new knowledge of understanding each and every biomolecule. Such combinations are called as biomolecules. I would rather say the complex biomolecules are carbohydrates, proteins, nucleic acid, lipids, etc. And out of which proteins and carbohydrates plays a very essential role in our body, and you know how important it is. Of course, we have vitamins and minerals. They also play a major role because we need that for our immunity development. So let us focus on carbohydrates. Carbohydrates are primarily produced by plants and they form a very large group of naturally occurring organic compound. Everywhere you find this organic compound which is being useful for the derivatives of all such compounds like carbohydrates or proteins. Some common examples we have cane sugar, glucose, starch, etc. Most of them have a general formula CxH2OY, which means it's a hydrate of carbon. It has got a hydrate of carbon. That many hydrates are there in that particular carbon. That's why we have the formula CxH2OY. Now most of them, if they have this formula, it doesn't mean that any compound which has this formula will be called as a carbohydrate. Example, if you see acetic acid, or I would say ethanoic acid, has the same formula, but it is not a carbohydrate. They belong to an acid group, that is carboxylic group. Similarly, I would say that anything that is having such carbohydrate may not be having the same formula also. So how can I define what is a carbohydrate? These are optically active polyhydroxyaldehydes or ketones. Polyhydroxy, which means there are more number of hydroxy group in that particular compound and they are optically active also, or any compound which produces polyhydroxyaldehydes and ketones will be called as carbohydrates. That is, any compound which on hydrolysis are yielding me polyhydroxyaldehydes and ketones, I would name them as carbohydrates, in which the carbohydrates that are sweeter in taste will be called as sugars. Now let us look on the classification of carbohydrates. Carbohydrates can be classified first on the behavior of hydrolysis. Any compound that I take, if on hydrolysis, is going to yield me different products, depending on its behavior, I am going to classify them as monosaccharides, disaccharides, polysaccharides. From the name, it's very well understood that if it gives only one product, I call it as monosaccharide. That is a carbohydrate that cannot be hydrolyzed further to give a simpler unit. That's the only one unit which is available, which further on hydrolysis do not yield any other product. I call them as monosaccharide. 20 monosaccharides are known to occur. Example, I can say glucose, fructose, ribose, etc. Now what about oligosaccharides? Oligosaccharides will come under the category of disaccharides, which means carbohydrates that can yield from 2 to 10 monosaccharides unit. From 2 units to 10 units of monosaccharide units can be brought down by the hydrolysis of an organic compound of a carbohydrate. Then such a compound we call it as oligosaccharides. If it gives 2 units, you call it as disaccharides. If it gives 3, you call it as tri, then tetra, penta, hexa, hepta, nono and deca. So depending on that, we call them as a group which is oligosaccharides. And the common examples you can see, sucrose. Sucrose on hydrolysis gives 1 molecule of glucose and 1 molecule of fructose. But maltose on hydrolysis gives only 2 molecules of the same compound, that is glucose. It does not, I didn't mean that it is 100% necessary that it should give 2 different types of carbohydrates. No, it can give the same molecule but in different units. The last one is polysaccharides, that is more than 10. If it yield a large number of monosaccharides units on hydrolysis, you call it as polysaccharides, and the best example is starch, cellulose, glycogen, gums, etc. Now they are not sweet in taste. Polysaccharides are not sweet in taste, so you call them as non-sugars, because I told you any carbohydrates that are sweeter in taste, you call them as sugars. So some polysaccharides may not be sweeter in taste, so you call it as non-sugars. Further, carbohydrates can also be defined as reducing or non-reducing sugar. Reducing means the capacity to reduce, to undergo reduction. Now those carbohydrates which can reduce fillings and tollens are referred as reducing agents, because we know it can be an aldose or it can be a ketone which does the reduction effectively. So if the tollens and the fillings reagent can be reduced, so those are called as reducing sugars. Further, we are going to classify these monosaccharides. Now we are going to learn about monosaccharides, where we study in detail only about glucose and fructose. Depending on the number of carbon atom and the type of functional group present in them, we are going to classify them as 2 different groups. One is an aldose, the other one is a ketose. So if that particular monosaccharide contains an aldehyde group, you call them as aldones, and if it contains a ketone group, you call it as ketose. So now let us learn about preparation of glucose. Glucose occurs free in nature and as well as in the combined form, and you know it has a good fruity smell, and also about the fruits and the honey. First preparation is from sucrose. That is, if sucrose is boiled with dilute hydrochloric acid or sulfuric acid in alcoholic solution, you get your glucose and fructose in equal amount. Let me show you the reaction where we have cane sugar, which is nothing but sucrose, C12H22O11, which on hydrolysis in presence of HCl or sulfuric acid will give equal amount of glucose and fructose. So, the molecular formula for glucose and fructose is C6H12O6, which we have been learning from years. Next one is from starch. From starch is obtained on hydrolysis with dilute sulfuric acid. When you boil starch, that is C6H10O5. I have written here N, which means N molecules because it is a polymer. N molecules of starch or cellulose on hydrolysis in presence of mineral acid. It gives me N molecules of glucose alone, where fructose is not been obtained. Now we will learn about the structure of glucose. So let us learn about the structure of glucose. Glucose is an aldohexose. When I write aldo, you know aldehyde group is present. Hexose means you have 6 carbon atoms, and it is also called as dextrose. Another name for glucose is dextrose. It is a monomer of many of the larger carbohydrates like starch, cellulose. What do you mean by that? These are polymers and this is a monomer. We have studied in polymerization. You remember, children, how that reaction takes place? You get a monomer and a polymer. So let us see the properties of glucose or how the structure of glucose is maintained. First important point is its molecular formula was found to be C6H12O6. So that is the molecular formula for glucose. On prolonged heating with HI. What do you mean by prolonged heating? Continuously when you heat glucose, it forms N-hexane, which means we know on heating the water molecules will get evaporated or it can be removed easily. So it forms N-hexane where the OH, all OH groups have been removed. What does it suggest? When it forms N-hexane, now we know this is a structure of N-hexane. From the structure, that is from the product, we can find out that there are 6 carbon atoms which are presenting the straight chain, which means glucose on prolonged heating with HI gives N-hexane that confirms the presence of 6 carbon atoms which are arranged in a straight chain. The third point says glucose reacts with hydroxylamine. This is hydroxylamine NH2OH to form an oxime and adds a molecule of hydrogen cyanide to give cyanohydrine. Do you remember, children, in aldehydes and ketone group we have studied about addition reaction where a nucleophile gets added into the aldehyde compound. So here when NH2 is reacting with glucose, NOH gets added. When HCN is added to glucose, you get CN group added. So which shows that there is a presence of carbonyl group. What do you mean by carbonyl group? It can be an aldehyde, it can be a ketone, right? So to confirm the presence of an aldehyde group in glucose, we do 2 addition reaction. One glucose with hydroxylamine, second one glucose with hydrogen cyanide. The next reaction is glucose when it is oxidized, glucose gets oxidized to 6 carbon carboxylic acid, which is called as gluconic acid. That is, we use light oxidizing agent, mild oxidizing agents like bromine water where you get gluconic acid. So which gets oxidized immediately when you use an oxidizing agent? An aldehyde, that is a carbonyl group, gets converted into an acid group. So that again shows that the carbonyl group, which we confirmed from the third reaction, that the carbonyl group is an aldehyde group, because we know for ketone you need a strong oxidizing agent. So whenever I use a mild oxidizing agent, I get my aldehyde getting converted to my acid. That shows that this is a gluconic acid. Now what's the fifth property? It says that acetylation of glucose with acetic anhydride. So this is my glucose structure where I have CH2OH, CHOH 4 molecules. Instead of writing CHOH 4 times, I put CHOH and I put bracket 4, which means this structure is repeated 4 times with CHO. So this on treatment with acetic anhydride, what I am getting is a pentaacetate, that is glucose pentaacetate. How do I confirm this? This shows that the pentaacetate formation, there is a presence of 5 OH groups. How 5 OH children? I have 4 OH groups here and the fifth one is down at the last, that is at the bottom. So this 5 OH group, when it is treated with acetic anhydride, I get my glucose pentaacetate. That shows that this compound has 5 OH groups which should be attached to the different carbon atoms. There are 5 different carbon atoms which are having 5 OH groups, where all the 5 OH groups get acetated on treatment with acetic anhydride and the CHO group remains as such. So after this reaction, we have the next one is on oxidation. On oxidation, that is glucose, when it is oxidized, it is giving me succaric acid. What it is? Succaric acid, and this again gluconic acid. Now what does it mean, children, actually? When glucose as well as gluconic acid both yield this dicarboxylic acid. This is my gluconic acid. What is gluconic acid? The first one we saw, no, when it is used a mild oxidizing agent, you are getting gluconic acid. Same glucose with strong oxidizing agent, it is giving me succaric acid. So structure, how do I relate here? I am going to write the structure of glucose, succaric acid and gluconic acid. Now listen very carefully. When I am going to draw a line like this is my first carbon CH2OH. Now I have 4 carbons here. My second carbon, third carbon, fourth carbon, fifth carbon. So I am going to draw 1, 2, 3, 4 lines. On the top I write my aldehyde group and at the bottom I am writing my alcohol group, which is CH2OH. Now I have CHOH. How many? 4. So remember, this is an order H, OH, H. One side if you remember, you can write the other side. H, OH, H. So wherever I have written H, the opposite will be balanced by OH. Wherever I have written OH, the other side it should be hydrogen. So this will be the structure of glucose. And what about this? This is now CH2OH, OH. Last will be my acid group. So this is second structure is for succaric acid, and the third structure, sorry, this is for gluconic acid, and the third structure where I get a dicarboxylic group, this is succaric acid. So in both the structure I have CH2OH, till here it is the same, but this is my aldehyde which is getting converted to my carboxylic group, that is gluconic acid, which again yielding my dicarboxylic acid, that is succaric acid. So I have 2 carboxylic group with hydrogen, OH and H. Right. In this, what you need to learn is just the structure and no need to learn about the isomers of D plus and D minus. Now let us learn the cyclic structure of glucose. What do you mean by cyclic structure? Now we have written a straight structure, right? Instead of writing like this, we wrote like a branch. Now in cyclic structure, we will see there are some drawbacks where glucose, though it shows that it had an aldehyde group, though it says it has 5 OH groups, that is forming pentaacetate, it had a carbonyl group, and also we showed that it forms a dicarboxylic acid. But there are few drawbacks that which it could not satisfy. Despite having an aldehyde group, it does not give answer for Schiff's test. For aldehyde, when a Schiff's reagent is added, it should give a pink color, but this glucose is not giving that pink color, and it does not form any addition reaction with hydrogen sulfide. That is, with sodium hydrogen sulfide, it does not give any reaction. The pentaacetate of glucose does not react with hydroxylamine, which indicates the absence of free CHO group. Glucose, when it is treated with acetic anhydride, it is giving a pentaacetate, but that does not react with hydroxylamine to give an aldehyde group. So, we came to know that though the pentaacetate formation shows that there are 5 OH groups, or I can say there is a aldehyde group, but that pentaacetate is not reacting with hydroxylamine. So, that shows that there is no free aldehyde group present in the structure. Now, glucose is found to exist in 2 different forms. One is alpha, the other one is beta. Now, let us learn in detail about the structure of these. This behavior could not be explained by the open chain structure of glucose. It was proposed that OH groups may add to the CHO group to form a cyclic hemiacetal structure. Now, you can see here, this is my CH2OH, carbon, 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 carbon. H, H, OH, H, and I have here CHO, the 6th carbon atom, or in from the top if you come the first carbon atom. What I can do is, instead of writing OH here, I put a OH and here I connect it with my ring. So, this structure is actually written like this as alpha and beta. Understand children, there is a CHO, there is an OH group. When it gets connected, the first carbon gets connected to the 5th carbon, this O, double bond O becomes OH, and here it becomes a O. That is, this is my alpha structure, and what's the difference here? H, 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 OH, H. Here you can see hydrogen on the left, OH on the right, here the reverse of it, which is my beta structure. So, the 2 cyclic hemiacetal forms of glucose differs only in the first carbon, that is the placement of hydrogen and OH in the first carbon. This we call it as anomeric carbon. The first carbon where the hydrogen OH is different, you call that carbon as anomeric carbon, and the 2 structures isomers you call it as anomers. You call them as alpha and beta form, you call it as anomers. The 6-membered cyclic structure of glucose is called as pyranose or pyranose, and in analogy you call it as pyran. So, pyran is a cyclic organic compound with 1 oxygen atom and 5 carbon atoms in the ring. 1, 2, 3, 4, 5 carbon atoms, and you have an oxygen, that is pyran. So, when I am going to substitute with my HOH, now remember my first carbon, second, third, fourth, 5th carbon. So, how do I put my HHOHH? H on the left, H on the top again, OHH. That is, whichever we have written like this, HHOHH, I am going to put it on the top as HHOHH, and the last will be HCH2OH. So, this is all, you can fill it with OH group. Here the reverse of it will be beta. Wherever I started with H, I put OH. OH, H, OH, H, and the last will be CH2OH. So, that is the difference here. Children, understand this. H, H, OH, H, CH2OH, OH, H, OH, H, CH2OH. That is what is being written here. Okay. Okay. Now, we will get into the next one, which is our fructose. So, just like glucose, fructose is also a monosaccharide, but it has a ketone group, so it is called as ketohexose. Now, how it is obtained on hydrolysis of sucrose? So, same molecular formula, C6H12O6. So, I have here HHOH, a CO bond in the middle, and on the top CH2OH. So, here also I have CH2OH, on the top also CH2OH, in the middle I have HHOH, and I have a C double bond O. So, it exists in 2 cyclic forms. Just remember what you learned for pyran, and this is called as furan. So, why it is furan? Because the ring thus formed as a 5-membered ring with CO group here. So, this is called as pyran. The straight structure I can write like this. First carbon will be my CH2OH, second carbon, third, fourth, fifth and sixth. Okay. And here also first carbon on my right, because these are optically active compound, isomers. So here first, second, third, fourth, fifth, sixth. What is different in this? The CH2OH plays a dual role, it comes on the left and right. All other are the same. So if I want to write the furanose structure, CH2OH, OH, HH, CH2OH, OHH, CH2OH, and the opposite will be OH on the top, OH here, and I have hydrogen on the top, and this hydrogen will be at the bottom. So this will get the same, only here it will be a difference. So that is called as furanose structure or fructofuranose. Now we will see what are disaccharides. The two monosaccharides are joined together with a linkage which is called as glycosidic linkage. Two monosaccharides you are going to join with a linkage, that you call it as disaccharide. That is, sucrose is a disaccharide which on hydrolysis give D-glucose and D-fructose, and let us see how this is formed. These two monosaccharides, alpha glucose and beta fructose, will join together to form a glycosidic linkage. So here what happens? Here OH and OH will be there, that will be removed as water molecule, and these two will be joined with an oxygen which is called as a glycosidic linkage. So C1 of alpha glucose and C2 of the beta fructose will be giving my sucrose. Just learn the structure, you can draw and learn it by heart. You have to memorize the structure. Okay. Another disaccharide is maltose here. Alpha glucose and alpha glucose, both two alpha glucose units will be joined together. C1 of one and C4 of another alpha glucose will be joined, where one mole of water molecule will be removed and you get a maltose here, because we learnt in the first page that maltose is giving two glucose units. So when you join two glucose unit, you should be getting a maltose unit, which is a reducing sugar. Next one is lactose. Lactose is commonly used as a milk sugar because it is again sweet in taste, and it consists of beta glucose and beta glucose. Two beta glucose units will be joined together. C1 of one, that is beta galactose. This is galactose and this is glucose. C1 of galactose and C4 of glucose. What is the difference here? If you see OH, this is H. Beta structure, this is. When you have a joining like this from the top, not at the bottom, from the top, OH here goes here, you have oxygen and it joins with the C4 of glucose. So learn the structure again by heart, children. Next is polysaccharides. Poly means many. Starch is the main storage of polysaccharides of plants. It is the most important dietary source of human beings. It is found in cereals, roots, tubers, and also some vegetables. It's a polymer of alpha glucose and consists of two components, amylose and amylopectin. Starch has two important components which are amylose and amylopectin. If you see the structure of starch, it just continues, because I told you all the monomers get joined together to form a polymer. So when I put all the alpha glucose continuously, I am getting a linkage here. These are glycosidic linkage of alpha link. So I get my amylose. They may give you the structure and ask you to identify what it is. This is amylopectin, where one on the top, one at the bottom. These two will be joined at the zigzag way. Okay, this is called as an amylopectin. You may never be asked to draw the structure, so you need not worry about it. I have given the focus area points to you, will be sending you the link. You just have to learn those focus areas. Okay. Next one is cellulose. Cellulose, if you see, it's an important organic substance in the plant kingdom, and it's a straight chain polysaccharide. Straight, it gets composed with beta D glucose units, which is joined with the C1 and C4 of the next glucose unit. And the last one is glycogen. The carbohydrates are stored in animal body as glycogen. It is an animal starch because its structure is similar to amylopectin and it is highly branched. It is present in liver, muscles and brain. Okay. So when the body needs glucose and enzymes break into glycogen, down to glucose, and then it is also found in yeast and fungi. These are some of the important things which you may get from this chapter. Some of the importance you can learn from about carbohydrates which are necessary. From the next class we will get into proteins. Okay. So take care. Until then, see you in the next class. Bye.